Good afternoon, colleagues. Today I will present our project in automatic design of a dictionary of verbal governance for the Russian language. Theoretical linguistics and natural language processing are aimed at different problems. In theoretical linguistics, it's important to find some most bright and important cases which demonstrate the structure of a language or its rules. In natural language processing, we need a comprehensive database which contains information for almost all possible cases. It's important because if we don't have information on some phenomenon, we don't know if it's possible in the language or we just lack of data. Existing dictionaries are following the first way. They consist of information about the most frequent and important verbs and provide just a few examples enough to drawing conclusions. The biggest dictionary contains information about possible combinations for just 1000 verbs, but not verbs only, starting from character A to Z. That is middle of Russian alphabet. It also describes just most important cases and couldn't be used for NLP tasks. So, in this project, we aimed to create a new dictionary which will be useful for different users. For Russian language learners who want to know if a combination is correct or not. For researchers who need statistical information to prove their theories. And for NLP developers who need comprehensive databases. Such a database should meet several requirements. It should contain information about verbs and their possible combinations with nominal and prepositional phrases. It should be composed from a big collection of natural texts of different styles and genres. It should be collected using simple and easy accessible tools. The precision of collected information should be higher than 95%. We used the following method. Firstly, we collect and parse Russian natural texts. Then, we calculate statistics of mutual co-occurrences of verbs and their dependent nominal and prepositional phrases. After that, we formulate a lexicon of prepositional governments, which demonstrates the correct usage of Russian prepositions and grammatical cases governed by these prepositions. Finally, we filter out the gathered statistics according to the collected lexicon and some other empirical rules. Let me consider all these steps in more details. We gathered a big collection of Russian texts consist of 3.5 billion of words divided in the following topics. The collection was parsed using Deep Pavlov library, since we found that it provides better precision and productivity. Then, we gathered statistics on frequency of co-occurrences of verbs and their dependent nominal and prepositional phrase. After that, we calculated frequencies of co-occurrences of 132 prepositions, including compounds, with Russian grammatical cases. We found out that in most cases relative frequency less than 1% means that regular mistakes made by the parser. Such information was filtered out, the rest was manually checked. This provides us with information about possible combinations of prepositions and grammatical cases, named as lexicon of prepositional governance. We used this lexicon to filter out erroneously parsed prepositional phrases. Note that we filtered out some marginal or idiomatic rare combinations. However, we decided that precision is more important at this step. We also filtered out nominal phrases, eliminating all phrases which have negations, numerals, or quantitative adverbs, since they are defined by well-described rules of the Russian language. This is very important information, but it makes some crucial noise shifting statistics of verbal governance. We also found out that we could filter out some rare combinations for nominal phrases which have relative frequency less than a threshold dependent on the grammatical case. It can be explained by the fact that the parser makes some regular mistakes in difficult sentences. Note that we aimed to create not only the machine-readable database, actually a file in the pickle format that can be read by Python script, but a human-readable dictionary as well. For this purpose, we use the following algorithm. Let us consider a verb. Order its dependent phrases containing a preposition and grammatical case by the relative frequency. Note that here we consider a nominal phrase as a prepositional one with empty preposition. Leave not more than 5 most frequent combinations whose sum of relative frequencies is less than 80%. We also eliminate all combinations with frequency less than 1%. Such a simple method provides us with a pretty consistent dictionary which contains just the most frequent and thus most important combinations of a verb. Here we can see that in some cases there will be just one case used in most occurrences. But some of verbs don't express such preferences, combining with a lot of less frequent combinations. That is why we leave just 5 of them. We also found that 1,500 of verbs are mostly used with nominal case only. But note that some of them have frequency of occurrence just 1, so they should be eliminated. However, if we will consider the most frequent verbs, we will find out that our method provides us with reasonable results. For example, the verb clock is used with nominative case in more than half of its occurrences. We also compared our results with the active dictionary of Russian. Our dictionary consists of about 2,000 of verbs starting with characters from A to Z, while active dictionary consists of just 1,000. So, up to 19% of our verbs, depending on their frequency, were found in the active dictionary. We also hit the active dictionary by the average number of combinations per verb, more than 2 for AD, and about 20 in our case. Our dictionary provides 5.5% of mistakes in nominal governance for the top 100 verbs. These are divided between dative and instrumental cases, 17 and 6 mistakes respectively. However, we made less than 5% mistakes for the top 300 most frequent verbs. Considering prepositional phrases, we can state that the level of mistakes is less than 3%. Note that our dictionary provides just information about verbal combinations, but not about semantics of co-occurrences of nouns. However, our method could shed some new light on the difference between arguments and adjuncts. We also proved the applicability of our method to the Polish language, but we did not calculate any precision. We have published source code and evaluation of our method at GitHub repository. However, the resulting dictionary consists of 1 GB of data, so we failed to share it on GitHub or other free and robust resources. Anyway, the data are publicly available by request. Please don't hesitate to contact me by an email. Thank you for your attention.